All right, you guys, we're on the last week of lecture videos. This is the last set of lecture videos that you guys are going to get for the whole year. But there are a few of them. So we're going to get into the trig identities today. This is going to take us through the rest of what we do for the rest of this year. And there are a lot more on the paper that you're looking at than what the book gives you, but these are all the identities that you're going to see next year in pre-calculus. The best thing you guys can do is find a place to store this sheet or even make flashcards out of the identities and just know them really, really well so that you can apply them, especially to those more challenging problems that you guys are going to see next year in pre-calculus. But this is our intro to trig identities. I'm not going to prove them all necessarily, but you guys are welcome to look up on the internet how to get those proofs if you're really interested. All right, so the reciprocal identities, something hopefully that isn't too hard to remember here. We're just looking at the reciprocals of all of the different trig functions. So sine, the reciprocal is cosecant, so if we can rewrite the sine of theta as 1 over the cosecant. For cosine, we can rewrite it as 1 over the secant. Tangent, 1 over cotangent theta. Secant then is going to be 1 over the cosine of theta. Cosecant will be written as 1 over the sine of theta. And cotan will be written as 1 over tangent theta. All right, so those are just the reciprocal identities. We're using the reciprocal properties there. Something slightly different, I'll refer to them as the quotient identities. Tangent can always be written as sine over cosine. That comes from knowing tangent is y over x, opposite over adjacent. We can also rewrite that as secant of theta over cosecant of theta. So we can use those reciprocal identities as well. The way that I remember tangent, if you can remember it as sine over cosine, then secant over cosecant, because secant starts with an S, so does sine, and cosecant starts with a C, so does cosine. Also, you could just apply the reciprocal properties of sine and cosine and then simplify. All right, cotan then, if it's the reciprocal of tangent, it's then going to be the cosine of theta over the sine of theta. We can use the reciprocal identities as well on those. We can represent the cotangent of theta as the cosecant of theta over the secant of theta as well. All right, more complicated are the Pythagorean identities. Your book is only going to give you the 3 that I'm going to talk about first, and then I'll show you why I've given you guys 9 lines here. The Pythagorean identities come from using the Pythagorean theorem, thus the name. So I'm not going to go through the proof there, but that's how we derive these. The first one, and kind of the one you guys might have seen already in geometry, is that cosine squared plus sine squared is always equal to 1. If we're looking at the unit circle, remember that the hypotenuse of all of these angles that we can draw, the radius of the unit circle is 1, so the hypotenuse is 1. A squared plus b squared is equal to c squared. That's kind of where we're getting that cosine squared plus sine squared is equal to 1 deal. Okay, before I write downwards, we're going to go across. The second set of Pythagorean identities then comes from knowing cosine squared plus sine squared is equal to 1. Here's how we get the next set of Pythagorean identities. If I were to divide every single term in this identity by the cosine squared of theta, we would end up with 1. And then sine squared over cosine squared is tangent squared. And then 1 over cosine squared is secant squared. So that's how we get the next set of Pythagorean identities. So the next set is 1 plus tangent squared of theta is equal to the secant squared of theta. Again, we can always get that if we know cosine squared plus sine squared is equal to 1. All right, the last set, and then we'll talk about what we're going to write underneath, is going to come from going back to cosine squared plus sine squared. Instead of dividing by cosine squared, what if we divide everything by sine squared? So what happens when we divide everything by sine squared, we can do that because we've got an equation we know is true. This becomes cotangent squared. This is 1, and then this becomes cosecant squared. So we're going to see that last set of identities. All right, so those are our Pythagorean identities. Here's why I've given us lines underneath. What's going to happen is we're going to rewrite each of these Pythagorean identities to equal something else. So instead of having it equal to 1, maybe I want to move things around. So I'm going to move the sine squared to the other side. The second identity that goes along with this is that the cosine squared of theta is equal to 1 minus the sine squared of theta. And then the last one, I'm going to subtract cosine squared from both sides. So sine squared is equal to 1 minus cosine squared of theta. So they're all related to the one we started with at the top. I'm just moving things around. All right, if I subtract tangent squared from both sides, we get secant squared minus tangent squared is equal to 1. And then if I subtract 1 from both sides, I get tan squared is equal to secant squared minus 1. And then lastly over here with those cotans, if I subtract 1, I get cotan squared is equal to cosecant squared theta minus 1. And then 1 is equal to cosecant squared theta minus cotangent squared theta. Right? So really all you need to know is the first line of each of those Pythagorean identities, and then you can just kind of move things around. So the first line is definitely the most important on that one. All right, we're going to move on to the cofunction identities. These are a little weird. We'll see them being used in an example later on in the notes, and I think it'll be a little bit more clear what's going on there. But for now, we'll just kind of remember what that is. The cofunction identities look like this. The sine of theta can be also rewritten as the cosine. We're going to stick in radians today of pi over 2 minus theta. Cosecant can be rewritten as the secant of pi over 2 minus theta. The cosine of theta can be rewritten as the sine of pi over 2 minus theta. Secant can be written as the cosecant of pi over 2 minus theta. And then tan and cotan, we're just going to swap. That's the cotangent of pi over 2 minus theta, and cotan is the tangent of pi over 2 minus theta. Now, just kind of like really quickly to give you an idea of where these cofunction identities come from. It's not something you necessarily have to know if you can remember the cofunction identities, but let me just draw a triangle. That is a right triangle. It is super messy, and let's call that angle theta here. Now, we know, let's say I'll call this y, x, and r, right? The sine of theta is equal to y over r. But if I were to turn this right triangle, or we could look at it in terms of this alpha. Alpha is 90 minus theta. Because we know all the angles in a right triangle or in a triangle add up to 180 degrees, alpha is 90 minus theta. That's how we would solve for it. So we can say that the sine of theta, if the sine of theta is y over r, then the cosine of alpha, or the cosine of pi over 2 minus, or 90 minus theta, is also y over r. So that's where the cofunction identity comes from. It comes from like turning a triangle and looking at the other angle in a triangle. Okay, next, the negative angle identities. I call these the odd or even ones. It really comes down to figuring out what functions are odd and what are even. So if we think back to the graphical definition of what's odd and even, anything with symmetry with respect to the y-axis is an even function. So if we could take each of these graphs, fold them on the y-axis, and they mirror each other, or the sides mirror, then we have an even function. There are only two even functions here. Everything else is odd. So cosine is an even function. So the cosine of negative theta, we can rewrite as the cosine of theta. We can get rid of that negative because cosine is an even function. If cosine is an even function, so is its reciprocal. The secant of theta, we can also get rid of that negative sign. Doesn't matter because they're symmetrical with respect to the y-axis. Okay, for all the other trig functions, these are odd trig functions. So what we can do is we can simplify that negative theta by pulling the negative to the outside. Just calculating the sine of theta and then timesing that by -1. Tangent is also odd, and so is cotangent. So we're allowed to pull the negative out, but we can't get rid of it like we can in cosine and secant. Cosine and secant, those are the only two even functions. All right, last ones here, sum and difference formulas, most complicated to remember just because they're the longest. And then we'll take a look at the notes here. Okay, So we want to calculate, or we want a formula that allows us to calculate the sum and the difference of two angles if we're looking at sine, cosine, and tangent. So let's write these out and then we'll kind of talk about them. The sine of a plus b can be expanded like this. It becomes the sine of a times the cosine of b plus the cosine of a times the sine of b. Similarly, the sine of a minus b, the sine of a cosine b, minus cosine A sine B. All right, cosine is going to look a little bit different. So the cosine of A plus B will expand to be the cosine of A times the cosine of B, and then we subtract the sine of A times the sine of B. And then very similarly, the difference here, the cosine of A, cosine B, and then this time we add sine A, sine B. So just write these down for now, and then we'll actually talk about it and kind of tricks on how to remember. All right, tangent A plus tangent B, that will expand to the tangent of A plus the tangent of B over 1 minus the tangent of A times the tangent of B. And then very similarly, the tangent of A minus B becomes the tangent of A minus the tangent of B over 1 plus the tangent of A times the tangent of B. Okay, so before we actually apply these, let's go back to the sine, cosine, and tangent expansions, kind of talk about maybe some tricks on how to remember these things. So with sine and the word same both start with an S. So when we expand the sum and difference using sine, the signs will stay the same. So if we had A plus B, we expand with a plus. We had A minus B, we expand with a minus. It's up to you to remember that it's sine, cosine, cosine, sine. Okay, so the sign stays the same when we're expanding sine. For cosine, if we take a look, cosine starts with a C, so does the word change. So when we expand cosine, we will change the sign. We had a plus, A plus B, and we expanded to A minus B, cosine A, cosine B, minus sine A, sine B. Again, when we had cosine A minus B, we had subtraction. We changed the sign to addition when we expand. And then lastly, tangent, the sign will match on the top, and then it changes on the bottom. All right, here's the last thing before we look at notes for 9-7. Here is how I remember the order of the expansion. We chant. Okay, here we go. Start up at the top. Sine, cosine, cosine, sine, sine, cosine, cosine, sine, cosine, cosine, sine, sine, cosine, cosine, sine, sine, tan, tan, 1 tan, 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 1 tan, tan. All right, however you choose to remember it, make flashcards, sing a song. These are things you're going to use next year in pre-calculus as well. And sometimes they come up on the SATs.